So earlier on this year we did a little bit with differential equations, and I just wanted to go over a few differential equation ideas that might be important, especially for those of you that may be going on to a full-on differential equations class in the fall. So we're going to look at section 11.2, which is slope fields. And so slope fields are really just used to represent a differential equation, but do so in a graphical way. So just recall, the derivative of a function tells you the slope of a function at a point. So like if we had dy dx equals 2x or y prime equals 2x, either way, those are saying the derivative of this function is 2x. So typically, if you think about functions, we represent a function with a curve along a graph. But to represent a differential equation, we're going to have to do this a little bit differently. We're going to do it with what's called a slope field. So let's look at one. Okay, so here we have the differential equation dy dx equals 2x. This tells us if you pick any of these x values along this graph, that the slope at the point should be 2 times the x value. So for any point, the slope is going to be 2 times the x value. So what is the slope at 1, 3? The slope should be 2 times the x value. If x is 1, 2 times 1 is 2. So if I now look at the point 1, 3, this point here, notice there's a positive slope, and its value is about 2. Rise 2, run 1. It just has this little tick mark. If I looked at the point -1, 3, the slope should be 2 times -1, which is -2. So if I look at the point -1, 3, I have the same kind of slope as we did for the first point, except for now it's negative. If I look at the point 0, 5, the slope should be 2 times the x value, or the slope should be 0. The slope should be 0. Here's the point 0, 5. We have a horizontal line which has a slope of 0. Okay, now I've asked you to sketch the solution curve through the point 0, 1. So we're going to start here. And to sketch the solution curve, you let the little tick marks, those little slope values, move you in the direction you want to go. So at 0, 1, it would take me here, and it would take me here. Following that, I would go here about, then it's telling me to still go up and to the right, so here, and so on. And going this way, I get something kind of similar, but like this. And now let's do the one, so that's my 0, 1 solution curve. Let's look at 0, -3. So starting down here at 0, -3. And what you'll notice, if you follow those tick marks, you're going to get something very similar to the first one, but just with the starting value that's different. But you get essentially the same curve. Why do you think those curves are a parabola? Well, the reason is they are the curves f of x equals x squared plus c. If you took the derivative of this thing, the derivative is 2x, and that matches our graph. Alright, so now we're going to try and match up some different differential equations to their slope fields. So let's start with dy dx equals x. In order to do this, what I suggest you pick some points along the graph and see if it could actually still be a possibility. Alright, so let's look at dy dx equals x. So what I'm saying is no matter what, the slope value should match the x value. So like let's say I pick this point here, 0, 1. That one could work because the slope there is 0 and x is 0. However, if I picked, like, say, this point here, the x-coordinate would be 3, which is a positive value. That's a negative slope, so that could not possibly be matched to the differential equation dy dx equals x. So let's take those away. That's not it. If I pick this one here, let's say I picked this point, 0, 2. The slope there should be 0. It's not. It's some positive value, so that can't be it. Let's take that one away. Okay, the third one, this is a possibility because if I pick this point, the slope is 0. If I pick this point, 1, 1 should have a slope of 1. Negative 1, 1 should have a slope of negative 1 because the x value there is negative 1. So this one appears to be matching up. I'm going to guess this is dy dx equals x. Alright, let's move on. Dy dx equals negative x. So that means to take the x value, make it negative, and divide it by y. So let's pick a point. Let's pick 3, 3. If I pick that point, I would take negative 3 divided by 3 and get negative 1 because we have 3, 3. If I pick this point here, that would be negative 3, negative 3. In other words, negative 3 would be positive 3. Divided by negative 3 is negative 1. That's about a slope of negative 1. If I moved over here, x is positive 3, y is negative 3. So I would actually have negative 3 divided by negative 3 is a value of 1. That looks like a slope of 1. And if I picked one last point, let's say here, if I pick that point, x would be negative 3 and y would be positive 3. So I'd have negative 3 is positive 3. Divided by 3 is 1. That looks like a slope of about 1. I'm going to guess this is my dy dx equals negative x over y. Okay, if I look at y prime equals x divided by y. So I'm going to take the x-coordinate and divide it by the y-coordinate. So this one here, this first one, let's pick a point. Okay, if I pick 3, 3, 3 over 3 would be a slope of 1. That to me looks too steep to be a slope of 1 there. However, if I come down here and I pick 3 over 3, that's a possibility. That looks like about 1. If I notice all those other points along that line, 5 over 5 should be a slope of 1. If I picked a point down here, negative 3 over negative 3 would be a slope of 1. Because of this line here, I actually know that this is going to be my dy dx equals x over y. Or really it's y prime is x over y. And you can play with other points to make sure that that indeed works. Like let's say, if I just pick this point here, that would be, x is negative 3, y is 4. That's a slope of negative 3/4. We've got a negative slope. So that's a possibility. And that leaves this last one to be dy dx equals y. Meaning if you pick any point along this graph, the slope should be the y-coordinate. So if you notice up here, all of these are positive slopes because y is positive. All of these are negative slopes because the y values are negative. So I know that's the graph of dy dx equals y.